Evaluate the indefinite integral. Use a capital C for any constant term. The antiderivative of 5 over the cube root of x to the 4th power dx. So we don't have any means of a quotient rule for antiderivatives. All we have is the power rule, and we need to rewrite things so that we can use the power rule. And that's what we will do here, because when I have the cube root of x to the 4th, something that is a cube root, that is the same thing as raising it to the 1/3 power. So essentially, 4 times a third, because when you raise an exponent to another exponent, you can simplify by multiplying those exponents. This is essentially x to the 4/3 power. Now, because that's in the denominator, we can make it a negative, or x to the negative 4/3 power, and rewrite this as the integral of 5x to the negative 4/3 power dx. Of course, when we do an integral, constants can be pulled out as long as they're constant multipliers. And all we have to concentrate on is this remaining term. Now, to integrate this term, what we do is we add 1 to the exponent. So we would be taking negative 4/3 plus 1, which would be negative 4/3 plus 3/3, or negative 1/3. So this is going to be 5 times x raised to the negative 1/3 power divided by that exponent, negative 1/3. Now, in terms of simplification, there's really not a whole lot that can be done. It's really just manipulating constants, so let's take care of that, get it as simple as possible. 5 divided by negative 1/3 would be the same thing as 5 times 3, or 5 times negative 3, which is negative 15. X to the negative 1/3 power is the same thing as x to the positive 1/3 power. And essentially, since that's just a root, you could leave it to the 1/3 power, or if you want to change it to a root, that's okay as well. You could make this the cube root of x plus c. Either way is fine. Generally, square roots we won't leave as something raised to the 1/2 power, but any other root it's okay to leave as an exponent if you like.